Get off your feet and on the edge of your seat. News and Views begins now. Once again, I'd like to welcome you right here to News and Views. I'm your host, Charlie Hale. Joining me today is Jerry Bauer, my producer. Jerry, it's good to see you on this side.
Good to be here, Charlie.
Yeah, you looking good, my friend?
Well, I'd be here more often, but I can't. I'm not fast enough to go back and forth and punch in buttons and sit out here at the same time.
You can't do both. Write me. Want to hear from you. News and Views, P.O. Box 924, St. Louis, Missouri 63188, or email newsandviews@knlc.tv. I don't want to waste any time here, Jerry. What you're going to talk about today is very interesting. I had Lee Berryman on last week, and you two guys are into science. Mm-hmm. And it bothers me so much that scientists always want to prove, a lot of them are atheists, unfortunately, and they want to prove that there isn't a God.
Right.
You two guys, have kind of enlightened me and schooled me how Christian scientists actually are proving now that they believe there's a God. Christian scientists are proving that there's a God. And one of the experiments you're going to be talking about today, and Lee talked about the God particle last week, but the double slit experiments. And that's kind of interesting because you're going to be talking about particles again, like Lee did, the God particle, the Higgs boson.
Yeah.
And what do particles do through this double slit experiment? I'm going to be quiet. I want to listen to this
first,
experiment.
let me just say that there is a good reason that you're hearing a lot of scientists attempting to use science to disprove God, because they have infiltrated academia today. They're in the colleges. There was a study out, and I forget the exact statistics, but something like 70% of all science college professors are atheists. So they're pushing an agenda.
Sure.
That's why you're hearing them using science to try to disprove a God. When the truth is, Charlie, that if one understands God and theology, and one understands science, they do not conflict. Mm-hmm. In fact, they complement one another. And the more we learn about quantum mechanics, which is relatively new science, the more we're seeing things that remind us that maybe something's out there. And this is not theology or something we're getting out of the Bible. This is something we're getting through scientific experiment. Mm-hmm. And this all started...
It's exciting.
Actually, in the 1920s, when a guy named Werner Heisenberg actually had the audacity to propose a theory. And just to refresh everybody's mind, when we're talking about particles, we're talking about atoms that consist of protons, neutrons, and electrons that orbit that. And then we can break the atoms down further into the individual particles. And it's these particles that we're talking about. And Heisenberg said, you know what? I don't believe that the path of an electron circling the nucleus of an atom even exists until someone observes it.
Interesting.
Well, back then people were scratching their head. Einstein was one of them. He said, God does not play dice with the universe. And other scientists come back to Einstein and said, don't tell God what to do. In other words, let us discover it. We may be discovering God. Who knows? But what I want to get to, actual physics experiments that show that quantum particles, like electrons, protons, neutrons, have intelligence. And they seem to know when they're being watched and when they're not being watched by an intelligent observer. Now, this sounds pretty weird. But you know what? It's science. It's not theology. It's not philosophy. It's called the double slit experiments. There's been several of them that's been accomplished, and they all show the same results. Dumb particles seem to have intelligence. And that's what this video shows.
We come back, we're going to get into this a little bit further. Right now I want you to take a look at this video. It's pretty interesting. Take a look.
And here we are, the granddaddy of all quantum weirdness. The infamous double slit experiment. To understand this experiment, we first need to see how particles, or little balls of matter, act. If we randomly shoot a small object, say a marble, at the screen, we see a pattern on the back wall where they went through the slit and hit. Now, if we add a second slit, we would expect to see a second band duplicated to the right. Now, let's look at waves. The waves hit the slit and radiate out, striking the back wall with the most intensity directly in line with the slit. The line of brightness on the back screen shows that intensity. This is similar to the line the marbles make. But when we add the second slit, something different happens. If the top of one wave meets the bottom of another wave, they cancel each other out. So now there is an interference pattern on the back wall. Places where the two tops meet are the highest intensity, the bright lines, and where they cancel, there is nothing. So, when we throw things, that is, matter, through two slits, we get this, two bands of hits. And with waves, we get an interference pattern of many bands. Good so far. Now, let's go quantum. An electron is a tiny, tiny bit of matter, like a tiny marble. Let's fire a stream through one slit. It behaves just like the marble, a single band. So, if we shoot these tiny bits through two slits, we should get, like the marbles, two bands. What? An interference pattern. We fired electrons, tiny bits of matter through. We get a pattern like waves, not like little marbles. How? How could pieces of matter create an interference pattern like a wave? It doesn't make sense. But physicists are clever. They thought, maybe those little balls are bouncing off each other and creating that pattern. So they decide to shoot electrons through one at a time. There is no way they could interfere with each other. But after an hour of this, the same interference pattern is seen to emerge. The conclusion is inescapable. The single electron leaves as a particle, becomes a wave of potentials, goes through both slits, and interferes with itself to hit the wall like a particle. But mathematically, it's even stranger. It goes through both slits and it goes through neither. And it goes through just one and it goes through just the other. All of these possibilities are in superposition with each other. But physicists were completely baffled by this. So they decided to peek and see which slit it actually goes through. They put a measuring device by one slit to see which one it went through and let it fly. But the quantum world is far more mysterious than they could have imagined. When they observed, the electron went back to behaving like a little marble. It produced a pattern of two bands, not an interference pattern of many. The very act of measuring or observing which slit it went through meant it only went through one, not both. The electron decided to act differently, as though it was aware it was being watched. And it was here that physicists stepped forever into the strange, never world of quantum events. What is matter? Marbles or waves? And waves of what? And what does an observer have to do with any of this? The observer collapsed the wave function simply by observing.
Jerry, that's some interesting stuff we just seen. Explain it, please, because that's way over my head.
All right, that's science. That's scientific experiment. That's not theology or somebody's religious musings. That's what science has discovered about particles. and that these quantum particles, when they are not being observed, they act like waves. But with the observer, they act like particles. Now let me try to explain that a little bit. Let's take electricity. Electricity can be looked at either as a particle or as a wave. It can be measured in hertz as a wave, or it can be measured in flowing electrons, particles, in amps. So all energy can be observed either as a wave or as a particle.
Sure.
So certain things in the universe have to behave as waves, and certain things have to behave as particles, solids. For example, you wouldn't want that coffee table to be a wave, because you put something on it, it's just going to go right through it to the floor. So that has to be a solid. But when I turn on these studio lights, I want waves to come out, or I wouldn't have light. Well, it seems that these experiments show that there is some sort of observer in the universe that observes certain things to make them particles and chooses not to observe other things to make them waves.
Interesting.
That makes the universe, it makes the reality of the universe indeed real to us, and allows us to function. The double slit experiments show us that for the universe to function the way it functions, there needs to be an intelligent observer somewhere in the process. Enter Frank Tipler. Frank Tipler is the chair of the physics department at Tulane University. And I will add that Frank was a hard atheist until he began this research. But Frank is a mathematical physicist, and he has shown mathematically that there is something out there that is quantum mechanics, and an intelligent pocket of quantum mechanics that he calls the omega point. Now, that omega point may be the observer. So let's just kind of summarize what we've shown here. We've shown that particles have intelligence. Tipler has shown that quantum mechanics, which is particles, exist out in the universe as an intelligent packet of quantum mechanics.
Okay.
Is that the universal observer? Have we found God?
Now, can these particles be in more than one place at any given time?
Oh, absolutely. Through superpositioning, that's another concept. If you may or may not be familiar with Schrodinger's cat, but
I'm not.
Okay.
Go ahead.
He did a mind experiment, Erwin Schrodinger, years ago, of a cat in a box, and this cat could be dead or it could be alive. This is a quantum cat. But you would never know, and I won't get into the details, but suffice it to say that you'll never know whether the cat is dead or alive until you open the box and actually observe it.
That makes sense.
So it's actually both until you observe it. And that little experiment is simply to show that quantum particles can be in all states at the same time. It's called superpositioning. So what does that tell us? If this intelligent quantum mechanics were God or some arm of God, it begins to flow over into theology. Have you ever, for example, heard of the term omnipresence?
Yes.
That's taught in the Bible.
Sure.
And I think, Charlie, that we've reached an era. Just keep in mind the God particle, the Higgs boson particle, wasn't even discovered until like 60 days ago or 90 days ago. This is all brand new. But I think we're reaching a time as we're going to see philosophy and theology and science begin to merge into one knowledge that's simply called the truths of the universe.
So particles have energy, correct?
Particles are energy.
And we are particles.
Right.
And we have energy in us, correct?
Yeah.
Okay. Now, is energy is created?
No. Energy, well, we get into the laws of thermodynamics. You may have studied these in 9th or 10th grade, probably glossed on them.
Remember, yes.
The second law of thermodynamics is the popular one, but there's another one called the first law of thermodynamics that says all the energy that exists was created via the Big Bang, and it will always be constant. The energy of the universe will always be constant. And out of the first law of thermodynamics comes another law called the conservation of energy. And that simply states that energy can never be created nor destroyed. It can only be changed. So let's just quickly tie that little bit of science maybe into to Christian theology.
Let me stop you right there.
All right.
I got to go to a break.
Okay.
Because I know where you're going.
All
What
right.
happens to our energy when
Yeah.
we die?
Does science say we can't die? Wow.
We'll be back. Welcome back. You just joined us. You're watching News and Views. We're into some deep discussion here. You know, the question was asked right before the break. What happens to your energy after you die? We're talking about scientific energy, and my belief, through theological beliefs, through the Bible, that this energy that you say can neither be created nor destroyed could possibly be your soul. Is that correct, Jerry?
Well, if we break all matter down, and Einstein told us through his formula E equals mc squared that matter and energy are the same things, just different expressions of the same thing. So you consist of matter, energy / energy. If you break that energy down into the most elementary substance that we can, other than getting into the quantum particles, atoms, then you are composed of energy. Your whole body consists of atoms, electrons, neutrons, and protons. So, if science says, through the conservation of the law of energy, that energy can neither be created nor destroyed, it can only be changed, can you ever die?
Well, you don't die, according to the Bible.
According to the Bible.
Now, there's your science.
I got my science hat on right now.
Yes, you do.
You know what? They don't disagree.
Sure.
Science says you can't die because you can never be destroyed. You can only be changed. What does Paul say? You're going to be changed in the twinkling of an eye.
There you go. That's when you go to your spiritual body, which is energy.
So did you know that scientists, even though they don't know it, believe in life after death? They just don't know what to call it. They don't even know if it's life.
This is awesome stuff.
They
though.
believe in existence after death.
This is awesome stuff, though. You know, you hear all these atheist scientists constantly always saying, well, there isn't a God. We had this Big Bang, the Big Bang thing. We talked about this before we went on.
Yeah.
Oh, would you just have a Big Bang and next thing you know, everything is like it is?
Yeah, well, they don't.
There's no way,
They
according
don't
to what you're
think
saying.
it through. Their common explanation for the origins of the universe are that, well, in the beginning was this primeval atom of infinite mass and density that suddenly exploded and the Big Bang happened, and planets and hills and valleys and everything formed from that. But wait a minute, that's what created the universe? How did an atom exist in something that was not yet created? How does something that doesn't exist contain something that does exist?
So this is how you're going to attack an atheist.
That's how I'm going to attack
How
an
would you?
atheist.
Okay, yeah, exactly. How would you go to an atheist, or an atheist come to you and
Yeah.
say, I don't believe there's a God?
Well, the first thing I would do is I'd ask him to do a Gedanken. That's German for mind experiment. I would ask him to take an apple that I would give him and to place it into a sack that doesn't exist and then carry that sack that doesn't exist around with the apple in it. Let him wiggle out of that one.
Okay.
Well, that's just about as dumb as his telling me that an atom was contained in a universe that didn't exist.
Very true.
Things that can exist cannot contain things that do exist, and that's really just common sense.
It is.
But if you want to really just warp the mind of an atheist, start him right there and ask him, so, well, then how did you get here? Oh, well, there was in the beginning, there was this atom that exploded, and he'll go on, none of it making any sense at all.
And your answer is going to be?
Well, my answer is going to be that if something doesn't exist, but then suddenly contains things that do exist, whatever created that had to have come outside the universe from someplace else.
That gets him scratching his head, doesn't
You
it?
know what I call that entity? God.
Amen, brother. It's neat. It's neat to talk about that stuff. Man, it's good stuff, Jerry.
It's
Good stuff, though. It's exciting to me to cover this stuff on News and Views. Some of this is over my head, and I'm sure it's over yours. The point in doing this is we want to prove to you there is a God. And Jerry is doing that. Lee has been doing that through science. We're utilizing science to prove there is a God, not that there isn't. This is what's really exciting to me, and that's why we're covering this. And I'm sorry if I'm over your head, but it's really interesting. But I wanted to hear what you had to say, because you're schooling me too, and this is exciting stuff.
good.
Stay tuned. Did you want to say something?
No, that's it.
You're done?
I'm done.